we are adopting, we created our product measure. My name is Owen, I will be majoring in applied physics.
My name is Deep Patel, and I plan on majoring in computer engineering.
My name is Cole, and I plan on majoring in mechanical engineering.
All right, so the first step in our design process is brainstorming. We have to come up with a problem. So after a couple days of thinking, we thought of a problem with measuring. I know it might seem a little odd, but this right here is the Belo horizontal overpass. July of 2014 in Brazil, during the FIFA World Cup, this collapsed, killing 2 people and leaving 22 injured. They sent an investigator, sent a search team through, measuring. Something wasn't measuring. The beam was cut too short, too long. This whole thing came down because of that. So, because of that, because of what we have learned from the research and our survey, found that a little under 87% of people think that measuring is a problem around our area and that it can be solved.
So these existing ideas out on the market right now, let's take for example this laser distance measurer. The problem with this device is that it requires a laser beam, which you need a surface to reflect back off of. So if you needed a measurement between a barrier for like 2 different rooms, these ideas would not suffice. So this is why we implemented our simple solution.
Simple solution that Deep's talking about is a formula. You guys might have seen this throughout school, even in your careers right now. Speed equals distance over time. Distance what we're trying to find the measurement between point A and point B, which means we only have to find the speed and the time for this last variable. So we thought, radio waves, they have a constant speed. They're moving at the same pace all the time. So as long as we know the speed, all you have to do is find the time now to get our distance. So we're going to show you a little bit of an example. I'm point A. I'm a transmitter of a radio wave. Pull at point B. Let's say hypothetically that the distance between us is 5 meters, but we don't know that yet. This ball right here, football, is a radio wave, traveling a little under 300 million meters per second. Not like that right now, but Deep, hypothetically, is going to have the time, and he's going to measure the time this ball takes from me to Cole. So I'm going to run that. We measured it out, and say it was 20 nanoseconds, which is about the time it takes traveling this distance. Let's see how we figure this out.
And here we got sketches for our designs, and then through certain criteria, we found our best design to be
the controller, which has a lot of ergonomic advantages and has a large display for easy to read.
Here's our sketches for our transmitter and receiver, and then through certain criteria, we also found our best design to be
a cube, which you see has a lot of flat surfaces, meaning you can put on any table, on any corner that you need, so there's less room for error. As you see back here, a lot of them wanted to have a wide base so they were easily to use and not fall over and easy to mount. How do we do it?
I'll tell you how. So we first started off using the Arduino software, which was based off the C++ programming language. To your left, you will see the transmitter code. This code sends out the signal, the radio wave. To your right, you will see the receiver code, which captures this 433 megahertz signal. We then progressed to the hardware stage. We connected the hardware on a breadboard. The blue you see is Arduino Uno boards. The green rectangles you see are the transmitter and receiver respectively. These arrows represent the lights that are being illuminated currently. So they are in sync right now, but you cannot see the delay between them because we just can't, the human eye just can't see that. But what we're trying to find is this slight delay in time, and we multiply this time by the speed of radio waves to find our distance. We then utilized Autodesk's Inventor, a 3D modeling program, to model our display and our transmitter and receiver based off of our sketches. What did we use, Cole?
We used components such as Arduino Uno boards and a transmitter and receiver set. We also used the software of Arduino and Autodesk.
Let me tell you who's going to buy it. Well, mostly we thought about construction companies, carpentry, surveyors, engineering, pretty much anybody that needs to find a distance or needs to estimate over distances. And then we thought maybe even into the schools, having kids be able to use them as a ruler so they know maybe science a little more exact measurements in their labs. And as you saw, $74.99 was our price, mostly because of the Arduino boards and the transmitter and receiver set, the beam a little bit under that, so we'll have to prop it from that. Wow, good buy, though.
Okay, so this device is very convenient to use as compared to like a ruler. If I wanted to measure the distance of this ruler or this table, I would have to take this ruler, then I would have to guess where that is and put it here. Then I would have to keep doing this until I get there and I'd say it's about 5 feet, which is really inaccurate because you're guessing where all this stuff is. But if you took our device, you put the transmitter here, you took it, you put it, the receiver flushed against this, you just press the button and it tells you the distance between them.
Also, compare that to a tape measure as well. I mean, you can use that. It tells you, brings all across onto the rulers, but then you have to hold one side, bring it all the way across, and use the other side, and there's still error with that as well.
Accurate results, we're getting down to 20 nanoseconds, which is very, very accurate and precise. Easily portable, you just have these two cubes and your controller, and you just carry that around. Easily fittable in your pocket. They're 2-inch cubes.
We'd just like to thank a few people in this end team who helped us throughout all 4 of our years. We had us throughout our times, really. Ms. Faith Kramer who helped us set up part of the planning and what we had to really think about, what were the key parts of our project. As well as Mr. Martin Brown, we contacted him via Skype. He's currently working on his PhD in computer science at FAU. He is very experienced with C++, which uses Arduino. And he actually, we're in the process of contacting another man, colleague of his, that is even more experienced, and he would help us create our programming and even manipulate it to be even more advanced than this man. Thank you very much. Do you have any questions or comments?
Yes, I'll start with some questions. How do you three, characterize your differences in your specialties in technology? As technology scientists, how do you three differ in your experience?
Well, I think I'm more mathematically or logically. That's how I would think. That's how I would make the project really. And so to have like the least amount of error, just I think about pretty much all the stuff that is.
And yourself, how would you differ from?
Yeah, as like my computer science background, I was always thinking about how am I going to do this? How am I going to utilize the software to find a timer? So I was always thinking about like the programming aspect of this the whole time, and then like hardwiring this together via our breadboard.
And yourself, how do you differ?
I'm more like science, like the
Like the science program.
yeah, sure.
That's close enough. So, in terms of creating collaboration, did you find that some of you wanted to go in different directions? And I guess what I'm getting at, how does one form a team with different interests that end up working together for a common goal?
Well, if anybody from our class would know that we don't really, well, we work together pretty well, but there are some times that we sit in the back of the room and you can hear us in the background, like
All the time.
But in the end, really, we all had a common goal, and we all knew what we wanted our project to do, so it all came together.
What was the common scientific language that when you were trying to communicate? You all have a different measuring stick for how you look at technology. So what was it the three-dimensional modeling? Was it illustration, or was it language that allowed you to communicate and work together?
Well, I think we've known each other for a very long time, and just like our friendship, like just utilizing our strengths, it like really showed here in our project.
So like most of us go through an engineering program, we thought we'd use the sketches, we knew how to sketch, as well as they are both in computer science classes, so they were able to use that knowledge.
Very interesting presentation. I enjoyed it, and you guys have actually gone into a lot of detail to come up with this. I'm curious about your proposed price of $74.95 or $99, whatever it was. What's your benchmark for that? Do you actually?
We researched the competition. The ones that we showed up there varied between I think 75 was the very lowest, and then a lot of them were upwards about 250. Like
Have you tested it any further than what you've shown us today? In terms of, distances, or maybe that really doesn't make too much difference, I guess, based upon your theory. As long as you've got both the transmitter and the receiver in place. Do you envision that gives you any problem in terms of placement of the receiver, say?
Well, if range is an issue, we can always just increase the strength of the signal by just adding an antenna or something, so it increases the range. But so interference was a common problem we realized we should address. This is why we selected the 433 megahertz signal, because there's no other Wi-Fi that can interfere with this signal.
Very good.
Just one.
What's the one thing through the whole process that frustrated you the most in the development? You can't say deep because no.
The program, definitely. That's why we contacted Mr. Brown.
So it's the programming part.
Yeah, that was the most.
That's pretty cool. Good.
Any other questions? Yes.
I might have missed it, but how much was it to buy all the materials?
Buy all the materials. Well, each of these blue boards you showed were about $25 each, and then the set was $6 of the transmitter receiver. The rest are pretty much they vary. They're not very expensive. So all in all, it's between $60 and $65. Yes.
How does it charge?
Sorry.
How does it charge?
It's battery operated. Our controller. Our controller has a display on it, so every time you press the button, the display changes based on your measurement.
If we would further our work, if we had more time, we would be able to set the signal to display what the measurement is.
Excuse me, $74 plus that you have into the device, is that just the equipment, or do you allow for profit in there?
We allow for, like I said, there would be mass produced, and we would have about $15 profit per, but they're pretty much all going to be throughout using the same materials, so we can buy the same materials, which lowers that cost of each material. Thank you.
Hello, this is Cordshield. I'm Brandon Paul. I'm from Airspace Engineering.
I'm Logan Romberger. I'm looking for the electrical engineer. So, I will be going first here. Why you need Cordshield? By a show of hands, how many of you have smartphones? Yeah. So, how many of you charge these smartphones overnight? So, there can be some problems, especially with iPhones, who are the worst offenders, with charging your phone overnight. As you can see, fraying and ripping. The bottom right picture is real. It's not fake. Somebody's iPhone caught fire in the middle of the night and gave them third-degree burns because of a frayed power cord. FireRecruit.com actually characterizes frayed power cords as the largest cause of home electrical fires in the United States. Definitely a severe problem and not one you want to have happen to you in the middle of the night. Third-degree burns are not fun. So, further justification, 86% of those surveyed, we surveyed 250 people with varying demographics. 86% say they have a problem with this. 74% say it includes phone power cords. Another popular option is laptop power cords, which are very expensive to replace. And over half said it happens at least moderately frequently. So, our solution here is the Cordshield. Seen as one, but you typically use at least two of them. The way it works, I'm going to demonstrate here. You take one of them and sort of twist it into the other, and they lock together. There's a free range of motion rotationally, but it does not bend very much, and that is the point. As you can see, there are two of them on a cord here. So the point is that it limits how much the cord is able to bend and prevents you from putting the cord, say, if you were to charge your cord, or charge your phone, sorry, with the cord, say, hanging under like this, that's going to make your cord rip up and fray. So the Cordshield, because it is rigid, prevents you from bending your cord so intensely, and also make sure that if there is stress on the cord, it will be on the product here, the cheap pieces of plastic, and not on the expensive power cord. It's very, they're very durable. They're good for everyday charging, and it's a good product just because everybody charges. I mean, I asked all of you. It's a very common problem. And phone power cords can run up to $20, $30 if you buy the official ones from Apple. Laptop cords are closer to $100. So yeah.
Hey, right here.